Do you want to quickly find and merge data across multiple datasets? We are continuing our Spreadsheet Fundamentals series by looking at a set of lookup functions in Excel and Google Sheets today on ArtScience. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the Art+Science Analytics Institute, where our mission is to make you a better data analyst. We're continuing our Spreadsheet Fundamentals series by looking at lookup functions today. These features are essential for retrieving data in spreadsheets, providing you with the ability to quickly and accurately find and extract information from large data sets. Importantly, they also allow for seamless integration of different data sets, merging and joining. In this video, we will explore the HLOOKUP, VLOOKUP, LOOKUP, and XLOOKUP functions. Each function serves a unique purpose and can be applied to different scenarios in your data analysis. Once you have mastered these functions, you will be able to optimize your workflow, improve data precision, and make insightful decisions based on your data. For this video, just like every other video in the series, there is a step-by-step guide linked in the description below that you can use to follow along with the work that we are doing or practice afterwards. Also, we'll be demoing in Google Sheets, although all of these functions work the exact same way in Excel. Let's get into the spreadsheet and get to work. So here I am in my data set. This is the same data that we've been using for the entire Spreadsheet Fundamentals series. This is a transaction log for a school that teaches online courses, in-person live courses, and then courses that are a blend hybrid of both. In the previous videos, what we've been doing is really focusing on that class type messy column of data and cleaning that up. What we're going to do now with the lookup functions are actually bring in new data, merge data from other tables into this transaction log. But first, let's just get familiar with the HLOOKUP function. What HLOOKUP will do is search along a horizontal plane of data until it finds something that I've told it to look for, and then go down the rows of that column, some number that I have specified. Let me show you how that works. And a practical application here might be, since I have a customer transaction log, let's try to find the 100th customer. Maybe that's a promotion, maybe that's a giveaway that I want to use in my business. So I'm going to find the 100th customer, and since I have my transaction log sorted on date, that'll be easy to do. I'm going to begin by just typing here a column that we'll call 100th customer, and then engage the HLOOKUP function, HLOOKUP, which is going to ask me for a search key. That is the key that it'll go to in the horizontal array of data. And then the range that it'll search, that's the entire table. And then an index, which is the number that it should go down. So in this case, the search key is going to be the customer ID. That's what I'm going to search for. I want to find the 100th. I'm going to use the entire table of data as my range. And then the index, since I already have a header on this table, I'm actually going to go to row 101. That'll be the 100th, since I have one row at the top. Enter, and there you go. Customer number 0924. If I scroll down, let's go down to row 101, which is customer 100, and there it is, 0924. So that HLOOKUP function just really easily went through this large set of data and pulled that back. Is that valuable? Sure. Yeah, I could have just looked that up by hand, but what this allows you to do is automate that process, and particularly if you've got really large, unwieldy data sets, then this is a function that can help save you time. But where these functions really add value is when you create new variables in your data set based on another column of data. Let me show you what I mean there. So I've got this horizontally oriented table to the right where I have spend and the three categories of spend, the costs of the different classes, and then their corresponding class type. So I could use this data in an HLOOKUP function to create a standardized class type column in my data based on how much the customer spent on each course. So let me just add a column here. We'll call this class type HLOOKUP. And then using the HLOOKUP function, here the search key is going to be that spend in each row. The table, the range that I'm going to search will be this table here, and the thing that I'll need to do is anchor that table by adding my $signs to the numbers so that it always looks to that same table no matter what row I go to. And then the index will be 2. I want it to return that second row, which is the class type. And executing that, boom, autofill, there you go. I've got a standardized class type based on, tied to the amount of spend. And the HLOOKUP function, that simple little formula there, helps me do that. Now, is that valuable? Sure, yeah. But to be honest, I can't remember a time that I've ever actually had to use the HLOOKUP function in an actual analytical situation. This is primarily because the data sets that I'm working with are almost never arranged horizontally. My data sets tend to be much too large to fit in the horizontal format on a spreadsheet, which Excel's column limitation is 16,384, I think. And so if you think about a horizontally organized data set that is a transaction log or really any kind of deep customer data, you're going to exceed that limit pretty quickly. Plus, proper data organization really calls for data to be vertically organized for better readability and alignment with most analytical tools and processes. And so as a result, working with vertical oriented data has become the standard for me, making HLOOKUP really less applicable to my needs. This, though, is where the VLOOKUP function comes into play. And this is something that I do use very frequently. Let's jump into the spreadsheet and take a look now. Now here I am in my VLOOKUP table. What I've done is I brought in a new table, which is just a simple 2-column table of customer ID and then the zip code that customer ID is from. What I want to do is merge that table, the data ID, the zip code, into the transaction log using customer ID as a match key. Since this is a vertically oriented table, VLOOKUP is the right thing to use here. So I'm going to start by just creating a new column called this zip code. And then just like the HLOOKUP, which goes through a horizontal array of data, the VLOOKUP is going to go down a vertical array of data until it finds what I've asked it to look for and then return some column index from that point. So let me show you what I mean. We're going to initiate the function with the VLOOKUP command. The search key that I'm going to use will be the customer ID, that's my match key. The range will be that new column or new table that I brought in, and then the index will be the second column, the zip code. So executing this, I am looking for A2. I am looking in the range of M, N, and then I'm returning the second column, and there you go. What I have done now is gone out and found each customer ID in the zip code table and then returned the zip code for that customer ID. Now I could have merged any data here. If I had anything that matches my customer ID, maybe it is some kind of consumer segment I've created. Maybe it is the last product they bought. Whatever it is, as long as I have some kind of match key, I can use VLOOKUP to merge that data into a new table, allowing me to create more views, more variables, and more robust data. Now, there is one unfortunate limitation to the VLOOKUP function, and that is that when I have a match key, the data that I want to retrieve in my new table must be to the right of that match key. Because I'm basically saying find some data in this column and then move to the right a certain number with that index. If the data that I want retrieved happens to be to the left of that match key, the VLOOKUP function won't work. But this is where the LOOKUP function comes into play, because the LOOKUP function differs in that I'm going to specify the search key and then where to find that search key, and then also separately where to return a corresponding value. I'm not giving it an index, I'm not telling it to go to the right some number, I'm just saying find it in this column and then return the value in this column. So it doesn't matter if that value that I want returned is to the right or to the left, making the lookup function much more flexible. Let me show you how it works. Here I am in zip code. I'm going to do the same thing, just using the lookup function. I have a search key, I have the range of where it searches for the match, and then the result where it returns the corresponding value. So in this case, the search key is going to be my customer ID, just like before. My search range will be column N, that customer ID. What I want it to return is the corresponding value in column M, and there you go. What I've done there gets the same result this time because of the flexibility of the lookup function. It doesn't really matter where that result column is. I can just find it in the new table. Now, this is much more flexible than the VLOOKUP, but it's still not quite perfect. Let me show you what I mean, and you can test this in this way. I'm going to go to this first row of customer ID, and I'm going to enter a customer ID number that I know is not included in the zip code column table that I brought over. Let's just check 9999. That's a fabricated, bogus customer ID. When I hit enter, what happens? Well, it still returns a result of a zip code for me. Why? Well, because it just went through the columns of zip codes, customer IDs. It just found the one that was closest to 9999, which means it would have been the largest customer ID that we had, and it returns that zip code. The problem that we've uncovered here is that the lookup function doesn't allow us to return a value when that search key is missing in the next column. And this can be really problematic because sometimes when you're joining tables together, you don't know if all the data is contained in both columns or if there are missing values. So this is where our next function, the XLOOKUP function, comes into play. Let's take a look at that. Now here I am back in the data. Now we're going to look at the XLOOKUP function, something that is much more flexible, much more powerful than all the other lookup functions, and is in fact the lookup function that I use 95% of the time. So let's get right into it, and you can see the differences almost immediately. XLOOKUP, many things similar. It's still looking for a search key. Like the lookup function, it's going to look for a lookup range and then also a result range, so it doesn't matter if that result range is to the left or the right. But the one thing that's different is that now I have the chance to add in a missing value. So to complete this formula, I'm just going to say look for customer ID, look for it in the customer ID column, return the corresponding value in the M, and then if you don't find the search key, let's just return something that's called not known. We'll have that value show up. Enter, complete. Now I've gone out and I've matched the customer IDs into the new customer ID with zip code column and table and brought those zip code data in. But let's go ahead and do the test like we did for lookup. If I enter in this bogus customer ID number of 9999, this time, rather than just returning for me a result, I get the not known. Again, this can be really valuable because you're merging different data together, and it's impossible for you really to understand every single record in each table. Sometimes there are misses, and so this XLOOKUP function, with its flexibility, with the fact that it doesn't matter where that resulting range of data is located in the table, with the fact that you can use missing value, that it provides for a missing value as well, makes this the most flexible, the strongest, and most powerful lookup function that you can use. It's the one that I use almost all the time, and I think it should be the one that you use as well. Thank you so much for watching. If you haven't already, take a moment and subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Every single week, we are bringing new, exciting, and important videos on data analytics topics. We'd love to have you along for the journey. Also, be sure to check out the links in the description below for additional art science resources. We've got tons of them, and we'd love to share with you. Look for the next video, which will be on the basics of data visualization using spreadsheets. And until then, we'll see you in the next video.